Tesla's real bottleneck for Optimus was never the body, it's the brain, and the numbers behind that problem are genuinely staggering once you look at them directly. Musk has floated directing roughly 25% of Terafab's future AI capacity toward Optimus, which on paper works out to enough compute for around 1 billion AI5 class robot brains. That figure is a scale calculation Musk has described publicly, not a manufacturing promise or a production target, but it exposes exactly why Tesla is building a chip factory alongside a robot factory instead of simply buying compute off the shelf like most companies building AI products today. Start with why a robot needs this much silicon in the first place. If Tesla ever puts 10 million humanoid robots into the field, and each one draws up to 800 watts under a peak AI load, the theoretical ceiling comes out to roughly 8 gigawatts if every robot hit maximum compute simultaneously, which they wouldn't in practice, since millions of robots aren't all going to peak load at once. But the math still exposes something real. A million Optimus units aren't a million mechanical products, they're a million computers operating in physical space, and that changes the economics entirely. A factory robot doing one repetitive motion has a predictable, narrow compute requirement. Optimus is being built for the opposite, picking up unfamiliar objects, navigating changing rooms, reading human intent, adjusting mid-motion, and every added capability adds another layer of computational load on top of the last. That's where AI5 comes in. The figures circulating put it at roughly 2,500 trillion operations per second against 100 to 150 trillion for Tesla's current generation chip, alongside 192 gigabytes of memory and up to 1.5 terabytes per second of data movement. Worth being direct about this. Those are projected specs, and Tesla itself hasn't confirmed every final number will land exactly there. What's clear is the direction, a genuinely larger computational platform rather than an incremental bump. The reason that gap matters specifically for a robot: cameras, force sensors, and position sensors all have to get fused into one continuous perceive-act loop in real time, not processed one after another with any real delay, because a robot's decisions immediately move a physical body through physical space. A useful, if hypothetical, stress test for why this matters. Imagine a future humanoid operating in a surgical setting, parsing 3D visual feeds, tracking instruments, distinguishing healthy from damaged tissue, monitoring vital signs, and adjusting grip in real time, all simultaneously. To be clear, this is a computational thought experiment about what physical AI demands at the extreme end. It is not a claim that Optimus can perform surgery today, and any real medical application would require enormous additional work on safety, validation, and regulatory approval, well beyond where the robot currently stands. What the scenario does illustrate is the actual difference between a data center AI model, which can take its time and never has to physically move anything, and a robot where perception, prediction, and motor control all have to resolve almost instantly, or the robot loses its grip, its balance, or both. Raw compute headroom is what buys Tesla room to run larger models and process more sensor data without forcing Optimus to trade accuracy for responsiveness. The goal isn't a robot that calculates faster for its own sake. It's a robot that can handle situations nobody explicitly programmed for. But a powerful chip design is worthless without volume, and that's the second half of the problem. If Tesla is building factories capable of millions of Optimus units a year, every one of those units needs its own processor, memory, power delivery, thermal management, and packaging. And if chip production can't scale at the same rate as robot production, the semiconductor supply chain becomes the actual ceiling on how many robots Tesla can ship, regardless of factory capacity. That's the gap Terafab is meant to close, treating AI compute as infrastructure. Tesla builds directly rather than a component it purchases from outside suppliers. Under the 25% to Optimus scenario Musk has described, that share of Terafab's output would represent roughly 250 gigawatts of AI computing capacity a year, which at AI5's reference performance is where the 1 billion AI brains figure actually comes from. Again, a scale calculation illustrating what the infrastructure could theoretically support, not a stated production commitment for physical robots. There's real movement behind the chip itself, too, beyond the projections. Musk publicly congratulated Tesla's AI5 design team on X for reaching tape-out, the milestone where a chip design is considered ready to move into physical fabrication rather than remaining a simulation. Samsung's Foundry has separately said AI5 is slated for production at its Taylor, Texas facility on a 2-nanometer class process. Mass production is still a distinct later milestone from tape-out, but AI5 has clearly moved past the concept and projection stage into something with a real fabrication path attached to it. Tesla's economics claim for AI5 is the part that deserves the most skepticism of everything in this video. Up to 50 times AI4's performance at roughly 10% of comparable NVIDIA cost is a striking number, and it should be treated as Tesla's stated internal target, not an independently verified benchmark from a neutral third party. But if that ratio holds up even partially in real production silicon, the implication is significant. It would mean advanced AI compute cheap enough to embed directly into millions of physical machines, rather than concentrated almost entirely inside data centers the way NVIDIA's business is structured today. For scale, NVIDIA's data center segment alone pulled in roughly $75.2 billion in a single quarter, up 92% year over year, a useful reference point for just how valuable this category of compute already is before Tesla has shipped a single AI5 chip at any real volume. If Tesla's approach actually works as described, every Optimus becomes a physical AI endpoint in its own right, taking in real-world information, processing it locally rather than round-tripping to a data center, and acting on it through a mechanical body, multiplied across 1,000,000 units, and the comparison to today's robotics industry mostly stops making sense as a useful frame at all. None of this works as a purely mechanical manufacturing story. Tesla needs the actuators and the batteries, but it also needs the processors and the memory. It needs factories for the physical robots, and separately semiconductor capacity for the intelligence running inside them. Both have to scale together, or one becomes the bottleneck for the other. Which raises the actual question worth tracking here, more than task count or chip specs. How much unpredictability can Optimus actually absorb? An object slipping, a person stepping into its path, resistance changing mid-grip, before its intelligence, not its hardware, becomes the limit? We'll be watching AI5's path from tape-out to production closely. Subscribe to the Tesla Breakdown so you catch the next real milestone as it lands.